The percent composition of tartaric acid is 32.01% carbon, 4.03% hydrogen, and 63.96% oxygen. What is the empirical formula for tartaric acid? And then part B, what is the molecular formula of the acid, given that the molar mass is 150 grams per mole? The key here again, first of all, when we're talking with percent composition, this is on a mass basis, which immediately means grams. And we're going to assume 100 grams of tartaric acid. And since percent is part of the whole, that means that our carbon is going to be 32.01 grams. We have 4.03 grams of hydrogen, and we have 63.96 grams of oxygen. As I did in class, just multiply your 100 grams by the decimal equivalent of your percent, and you get those grams, of course, times 100. So you get the same number. So now we can just convert each of those three masses to moles, and then just find the smallest whole number ratio. So let's set our three elements here. We have carbon, we have hydrogen, we have oxygen. Starting with carbon, we have 32.01 grams. Let's scroll this up a bit. Times the molar mass of carbon, 1 mole, contains 12.01 grams. Grams cancel, and we do the math on that. We get 2.673 moles. For hydrogen, we have 4.03 grams. So we have 4.03 grams times 1 mole over 1.008 grams. It's molar mass. Grams cancel. We're left with moles. Doing the math, we get 3.99 moles. Lastly, our oxygen, 63.96 grams. We have 63.96 grams times 1 mole over 16.00 grams. Oops, grams cancel, not the number. And we do the math here, we get 3.998 moles of oxygen. So now we're going to assume these two numbers are the same. And what we're going to do now is divide all three of these numbers by the smallest number, since they're not the same. The smallest number is the number of moles of carbon. So I'm going to divide this by 2.673. That's going to give us 1. Divide this one by 2.673, and that's going to give us 1.49. We'll call that 1.5. And then divide this by 2.673. And that's going to give us 1.49 as well. We'll call that 1.5. So now we have almost a whole number ratio. We can multiply 1.5 times 2, and that'll give us 3. So we got to multiply the 1 by 2 as well. So we're going to multiply this by 2. That's going to give us 2. Multiply this by 2, and that's going to give us 3. We're going to multiply this by 2. That's going to give us 3. So our smallest whole number ratio is 2 to 3 to 3. For carbon, hydrogen, and oxygen respectively. So our empirical formula is going to be C2H3O3. So now for part B, they're asking us to determine the molecular formula for this compound, given that the molar mass is actually 150 grams per mole. So to do this, we're going to have to actually calculate the molar mass of our empirical formula. Again, let's make a note here. This is our empirical formula, which means it's simply the smallest whole number ratio, but that doesn't mean that the molecule has that smallest whole number ratio. So we're going to calculate the molar mass in the usual way. 1 mole of this compound is going to contain 2 moles of carbon. So let's start with that. So we got 2 moles. We're going to multiply by its molar mass, which is 12.01 grams per mole. And that's going to give us 24.02 grams. Going to hydrogen, same procedure. We have 3 moles of hydrogen and 1 mole of the compound, multiplying by its molar mass of 1.008 grams per mole. It's going to give us a value of 3.024 grams. And finally, oxygen, again 3 moles of oxygen in 1 mole of the compound, 16.00 grams per mole, molar mass, and 3 times 16 is 48.00 grams. So we add these up and we're going to get 75.04 grams per mole, molar mass of the empirical formula. Now in the problem, we're told in part B that the molar mass of tartaric acid is actually 150, which of course is not 75.04. So we're going to simply take our 150 divided by the empirical formula, 75.04, and that gives us approximately 2, which means that we need to multiply now our empirical formula molar mass by 2 to get the correct molar mass. And if we're going to do that, that means we have to multiply all of the subscripts, number of moles of atoms of each element in the compound, by 2 as well. So our empirical formula, C2H3O3, multiplying by 2, the subscripts specifically, we have C4H6O6. So this is our molecular formula.